board. Okay, so ABC. So we're on problem number 2. ABC should be a triangle, should look something like this. Now, the key with these transformations is sometimes if you do them out of order, it will end up in the right spot. But most of the time, if you do not do them in the order they tell you to, it will end up in the wrong position. So it is a sentence. It says if ABC has vertices 1, 2, 4, 6, 6, 1, determine A double prime, B double prime, C double prime after reflection over the y-axis, then, meaning next, translate to the right 6 down 7. So what do we have to do first? 6, 7. Reflection over the y-axis. So first thing we have to do is reflect across the y-axis. Is that a horizontal line or a vertical line? Vertical. So we're going to put in our vertical line, the y-axis, and we are going to count. Whatever's on the right side ends up on the left side. So you're going side to side. I would use your actual pencil to make the shape. We're going to use the colored pencils to like shade in the shapes. Because I know the colored pencils kind of get a little, like, I don't know, nasty. 1, 2, 3. You know what I'm trying to say. 1, 2, 3, 4. So a reflection just ends up the same. Just flipped on the other side. So it kind of looks like, ooh, it kind of looks like Halloween, like little eyeballs on a pumpkin. Does. So reflections and translations, whatever. They preserve distance, they preserve angle measure. It's exactly the same shape, just moved across the picture. So we're gonna, what this little box is, it's to help us. So the original points are here. After the first transformation, which is a reflection, after the reflection, where did A prime end up? -1, 2. Where did B prime end up? Good. And then C prime? Good. If you look and you compare the original points to the new points, what happened?
The X is negative.
The X became negative. And this is what I was talking about with, if you can remember the rules on this poster, that would be ideal. But if not, this is okay because you can draw this on a piece of graph paper and figure out where we go. If it's a reflection across the y-axis, the X changes negative, the Y stays exactly the same. If you can't remember the rule, it's okay. Just graph it out, see where it goes. The second transformation that I have to do is what based on the sentence?
Write it down. Okay, right. 6 down.
6 down,
Right.
6 right, down 7, 6, 7. So we're going to take not the original, pretend like that doesn't exist. We're going to take the one we just made. We're going to go right 6, down 7. That's going to be a double prime because it's the second transformation. So after I move it, 6, 7, where did A double prime end up? 5, -5. B ended up where? 2, -1. C ended up at 0, -6. Now, if we compare not the original, but what we just moved to this, notice that the numbers are different. We can't just say the X turns negative, the Y turns positive, blah, 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 blah. That's because when you're moving right and left and down and up, that's changing the exact location. So the numbers are changing. So for our rule, we're not just going to say one of the values turned negative. Well, we're not going to write it in words. X plus 6, because I went to the right. Y -7. You had an IXL on this, writing the algebraic rules to represent it. So I went right 6, it went down 7. So this is like my final answer. These are the answers that are actually correct after the double transformation. Those are the final answers. La, 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 la. Because you reflected it and then you have translated it. So the key is you have to go in order by what it says first. First period, I got it. Second period kept going out of order. I don't know why. Whatever it says first in the sentence is what you have to do first. So let's go back to number 1. Take a second, plot your coordinate points for number 1. It says, determine the location of trapezoid WXYZ. So it's a trapezoid. It's like a little plate trapezoid. Plotting the original. Not this one. So start by plotting your trapezoid points. -4, 6. -2, 6. This is Will baby. I don't know why I put prime. That's regular Y. -5, 4. Z. Okay, so this is my original. I don't know why I can't connect points for today. It's just a little baby. What does it say I have to do first for number 1? Left 3, up 4. So the first thing I have to do, it says translate to left 3, up 4, then, meaning next, then I reflect. So I can't reflect yet. I have to go left 3, up 4. So take a second. You're going to move your little baby trapezoid left 3 and up 4. So it's going to end up in that top left corner. Make sure you label your points as you go, because if you don't label them, then you try to write out the final answer. It's just gonna like confuse your brain trying to go back and figure out which letter is which. Let's 1, 2, 3, 1, 2, 3, 4. Okay, so once I went left 3 and up 4, where did W end up? -7, 10. Where did X prime end up? -5, 10. And then Y prime? -4, 8. And last but not least, -8, 8. So once again, if I'm comparing numbers, the numbers have changed. The reason why the numbers have changed is because I'm moving it. So if I'm going left 3 and up 4, how do I write out that rule in algebraic notation? X minus 3, y plus 4. Because left is subtracting, up is positive. And if you look at your numbers, if I take -4 and I minus 3, that gives me -7. If I have 6, I add 4, that makes 10. So technically, you could just do the math to find the coordinates, which is what we're going to eventually do. Eventually, we're going to do this where you're not given a graph at all, and you're just given this, and you have to figure out where it's going to be without the graph. But for now, we have graphs. So the next part, what do I got to do next? Reflect over the line y equals x. So it's not the x-axis, it's not the y-axis. It is y equals x. So what does a y equals x look like? Does anybody know? I think y equals x.
Flipping the numbers.
Yep, you flip your numbers, but what does the line look like? It's not on the x-axis. It is diagonal. It's positive. It's got a positive slope, so it starts at 0, 0, and it goes up because it's positive. And it goes all the way down technically to the bottom corner. So whenever you're doing a reflection over a crooked line, which is only 2 crooked lines, it's positive x, y equals positive x, and it's y equals negative x. Positive is increasing, negative is decreasing. These are the only ones I would suggest you use the rule. Because what people are forgetting is that this is technically reflecting across a diagonal. You have to double count because it's turning, because it's reflecting over a crooked line. It's weird. So whenever you have this, these are the 2 rules that you need to remember for the EOC. So you already remember the rule. What's the rule? You just flip them. So y equals x is just y x. We're not using the original points. We're using the points we just made. So if w was -7, 10, and all I'm doing is flipping it, what is it now? 10, -7. So all you're doing is flipping it. So take a second, flip all of your points. Just flipping it. If it's negative, it stays negative, it just flips. And then we're going to plot them. So you're just flipping it. Flip flop. Plot your points. You're going to see it's going to turn technically because it's reflecting over a crooked line. So it's not going to be just like vertical or horizontal. It's like flipping sideways. And end up this here. And the coordinate points that are technically the final answer is after both transformations. So once you finish with number 1, try number 1. No, so you're, yeah, the y's are negative. But you're not like, you're still like plotting it like normal. You're going over 10 and then down. You're not going down 10 and then over. So it's like, even though we're flipping the coordinate point, it's still plotting it like a normal point. Number 1 kind of looks like a diamond, like a rhombus. We're Lothar, so it's like crooked.
Is the rule number three, negative X,
You flip it and you make it negative. So negative y, negative x. It looks so cute.
Nice. I noticed the light instead of the cameras.
That's okay. Did they care? If you, I guess not, if they printed it.
I can try it.
That's scary. Have you driven?
I know.
Your friend?
Family.
Oh, okay. Family friend is gonna teach you how to drive.
Yep.
Holy moly.
Mine said she doesn't.
Yeah. Whenever I started driving, I almost like got my mom into an accident. I still remember it's like burned into my brain forever.
I'm still also from Oregon donor.
You're also an organ donor? I think I used to be an organ donor. I don't think I am anymore. I think I've had them take off. That's pretty cool. Holy. Okay, so y equals negative x. What's that line look like? Like, y equals negative x. What does it do?
Oh, it's diagonal.
It's diagonal. Okay, okay. Is it like increasing or is it decreasing? It's decreasing because it's negative. So it starts high and ends low. Oh snap. Okay. Negative. For these, some of you have good eyes and can tell where it's going to be at. I would not do that. There's only two so far that you need to remember for the EOC. The rule for this is on that poster. We're going to flip it and we make it negative. So for the rule for the reflection
Negative y.
is negative y, negative x. Okay. So if let's start with L because I don't like how I is like the same number. So if I start with L, if I flip this and I make it negative, but it's already negative, what are double negatives going to make? Positive. So if I flip it and I make it negative, but double negatives, what is the coordinate point? 5, 3. Yeah, because if I put a negative with a negative, two negatives make a positive. So I flip it and I make it negative. If it's positive, it becomes negative. If it's negative, it becomes positive. So it basically changes the sign. So K, if I flip it and I make it negative, what's it going to be? 5, 0. Because I flip it and it becomes positive because it was negative. 0 is neither positive nor negative, so it's just neutral. What about J? 2, 5. And then the last one, which is I, is 2, 2. If you just try to figure out where it goes, some of you can figure out where it goes, most of you cannot. I would just remember the rule. Only for the crooked lines. The other ones you can just draw out. If it's crooked, use the coordinates. So plot your points. Yup, yup.
So negative. Like,
So if it's a y equals negative x, that's a crooked line. So that means that you flip the coordinate and you make it negative. Unless it's negative, then it becomes positive. Okay. So if they give you the equation, this is my equation. And I'm using this formula, which is on this picture. Yeah, but the problem is they're already negative. So if I'm making them negative and they're already negative, then they're positive. Yeah, so you're flipping it and then you're flipping the sign. Okay. So once you have your, this one, then what are you doing? Right 5 up 5. That one's easy. So move your picture, the new one, right 5 up 5. Figure out where it's at on your graph. Write your coordinate points out and try to write the rule to represent right 5 up 5. Okay, where did I end up? 7 7. Where did J end up? 7 10. Okay. 10 5. 10 8. What's the rule to represent right 5 up 5? X plus 5, y plus 5. Because you're going right and you're going up, so that's increasing, so it's literally changing numbers, it's adding. So technically nothing new. It's just literally combining the things that we've done. The only ones that you technically need to use the equation for, like the coordinate points for, is actually whenever it's a crooked line. If it's x-axis or y-axis, you could just draw it. So on the back side, you have the top one, number 4, and then you have the 4 at the bottom that do not have the little chart. You don't need the chart. The chart is just there to help you. So if you want to write out the coordinates, you can write out the coordinates. Most of the ones you do not need to write out the coordinates. If you feel like you can do it without it, don't do it. So start with this one. Doctor, stop it. Perfect. Plot your original. Let me know if it gets good. Let me know if you need help. Then you're gonna take a picture of it and put it online. Just that. Yeah.